Vectors Part 5, Position Vectors. Now in this part of the chapter, we'll learn how to convert a coordinate to a column vector. Now remember, column vector form is given as the number of units that we travel on the x-axis direction and the y-axis direction. So for example, if I'll give you a point P to be the point 3, 5, where will this point be on the y and the axis system? The coordinate axis have the x and the y-axis direction, and the original center here is always the letter O. So now if I have to mark the point of this coordinate 3, 5, this will be 3, 5, and we'll have the point P at this position. Now the moment we have this coordinate, it tells us that from the origin, I can travel 3 units on my x-axis direction and y units on my y-axis direction to give me the vector O to P to be 3, 5. So when we have a coordinates, the instinctively first the information to write down is that the position vector O to P will now be traveling from the origin. I will move 3 units on the x and 5 units on the y. So when we are given a coordinate, we must be able to write down the position vector immediately. So let us check with a few more types of questions. For example, if I were to give you the point A to be 6, 2, what will be the position vector in this case directly? So for example, I have 6, 2, this point over here, point A. It means I've traveled 6 units on the x-axis, 2 units on the y-axis, and this will be the vector O to A, OA. So immediately we know that OA is the vector 6, 2. Have you understood the concept? Now vice versa, if we were to have the column vector for position vector OP, where this is my x-axis, this is my y-axis, and this is the origin. Okay, O to P is xy, meaning the x units and y units to be traveled. So for example, if I'll give you vector OP is column vector from 3, 2. So that means I will travel 3 units on the x-axis, 2 units on the y-axis to give me the vector O to P. That means the coordinates of point P will be 3, 2. So immediately when I see the position vector, this is from O, the origin, I will be able to know that the point P is 3, 2. So if questions were to ask you, for example, to find coordinates of P, that means you just need to find vector OP and you'll be able to transfer it into the coordinate vector form. So have you gotten the concept? Let's try one simple questions first. Now if A is the point 7, 0, that means what do we write intuitively? Immediately we know that the position vector from the origin O to the point A is given by 7, 0. So let's mark this point over here. O to A is 7, 0. So this is point A. Now they tell us that the vector A to B is 3, 2. So I'll have A to B, 3, 2. Find the coordinates of the point B. The moment they read this phrase, coordinates of the point P, it tells me I need to find the vector O to B. So question, how do I travel from O to B? I'm going to start at O. Where can I go to? Well, they've given me the point A. That means O to A is 70. So this will be O to A. And after which they tells me from A I can travel to B, which means A will be 3, 2, and I'll end up at this position, vector B. So I will have the column vectors. O to A is 70, A to B is 3, 2. That gives me 10, 2, which is also 10, 2, the point 10, 2. So therefore, coordinates, answering to the question, coordinates of B will be from X to be 10, Y to be 2. Have you gotten the concept? Let's try a few more questions. Immediately, if C is the point -2, 0, what do we know now? Well, vector, position vector OC will be -2, 0. If D is the point -5, 4, what do we know immediately now? The position OD is given to be -5, 4. And DE is 2, 3. Find the magnitude of CD. So in order to find magnitude of CD, we need to find the vector CD first. From C, where can I go to? Well, it tells me that C goes to O. And after that, from the letter O, I need to travel to the position D. So that means I started at C, ended at D, and I will have the column vectors. Oops, this is OC, and this is CO. What's the relationship? Well, they are negative of each other going in the opposite direction. And I'll have OD to be -5, 4. So therefore, our answers are -3, 4. And magnitude of CD will be taking square root of -3 square plus 4 square, and that will be a magnitude of 5 units. Next part of question, the coordinates of the point E. So they ask us to find the coordinates of point E. We must relate this to our position vector. What vector do I need to find? So the moment I see coordinates of point E, I will use the vector OE. So that means I need to find OE first. So vector O to E is starting from O. I can go to the point C maybe, because point C or point O, I can go to point D because I know that E is related to the point D. So I can go from O to D, and then I'll travel from D to E. So I'll start at O and at E. So now OD is given to be the vector -5, 4, and DE is now the vector 2, 3. Working out our answers, we got this. But answer back to our question. They want the coordinates of E. So I must remember to change this back to coordinates form. So this will be the answer. X will be -3, Y will be 7. Have you gotten the answer? Now, before we move on to answering more the harder questions, let's take a quick review on some of the following concepts that we have learned in the previous chapters as well. Now, firstly, let's find the magnitude of a vector U. So magnitude of vector U will be taking the square root of 6 square plus -8 square, and that gives us 10 units. So we know how to find a magnitude of a vector, and we also know that if I were to give a different variation of the vectors, I can perform scalar multiples of our vectors and do the addition that is required. So we'll get the following answer. And next concept, we know that if a vector is parallel to the vector u, that means the gradient will be the same. So that means a gradient over here for vector w will be p over 15 to be equals to the vector u, negative 8 over 6. We can find p to be negative 20. But before that, let's recall another type of concept for the parallel vectors. If w is parallel to vector u, we must remember that w is actually a scalar multiple times of the vector u. So whenever we see this, we must know that it is parallel. And if it's parallel, we must be able to write down this property. Now, with these basic skills, we are ready to move on to the next part of answering the harder questions. Question number 4. Given that F is the point for 3. Now, the moment you read this, what do? We need to know that OF is the position vector for 3. What's the next piece of information? G is the point 8, 11. So immediately we know OG is 8, 11. And Hitch is a point on FG such that, we see something with parallel and ratio. For this case, I'll write it as FH over HG to be equals to 1 over 3. Let's draw a simple diagram. H is a common point over here. You can see this. So that means F to H is 1 unit and H to G will be 1, 2, 3. This is G, 3 units. That means point F, H, and G are actually on one straight line. Okay, so now this is the information that's given in the question. Let's find as column vectors part A, F to G. If I want to start from F and go to G, F can go to the point O, and O can go to the point G. So F to O is the opposite direction as OF. So in that case, our vector will become negative 4, negative 3, plus OG 8, 11 to give us the answer 4, 8. Next, let's find what is FH. F to H is now 1 times 1 unit, but I only know the vector FG. So how much is FH out of FG? So FH is 1 unit, but FG will be 4 units. So FH is actually 1/4 of FG. That means 1/4 of the column vector FG is 4, 8. And FH will be 1, 2. Now it's quite clear to see that these two vectors are also parallel to each other. Find the position vector of H relative to the origin. That means they want us to find the position vector OH. So if I have the part A and part B answers, how can I find OH? O can travel to which letter? And H links to the letter F. So I can travel from O to F and then from F to the point H. So OF is given to be 4, 3 and FH was found to be 1, 2. Therefore, OH will be 5, 5. Have you gotten the answer? Question 5. EFGH is a parallelogram. Now, parallelogram have many equal vectors, and we need to know that the coordinates of E, F, and G are 0, 1, negative 2, 2, 1, 3, respectively. Immediately, what do we know about the position vectors? OE will be 0, 1, OG, OF, negative 2, 2, and OG will be 1, 3. Now, they want us to find the coordinates of H. It's a little bit difficult to imagine what this parallelogram will be, so what I'll probably do is I'm going to make a quick sketch. Okay, the x and the y axis. So EF, point E is 0, 1, so probably somewhere here, point E. And GAF is negative 2, 2, so probably F will be somewhere down here. And G is the point 1, 3, 1 units and 3. So this is 1, this is 2, and 1, 3. And 3 probably somewhere here. So this will be G. The parallelogram goes in this direction, E to F, F to G, and G now needs to go to H. Where will this point H be such that the direction flows? So in this case, this parallelogram over here will look something like this, and this will be point H over here. Now, parallelogram have a lot of vectors that are equal to each other. For example, E to H is the same as F to G. G to H is the same as F to E. So we have quite a couple of equal vectors. Now, they want us to find the coordinates of H. That means I need to travel from O to H. How can I go from O to H? O to H will probably be the same as going from O to a particular point. We can pick any point on the down here that we want. So since we have OE, OF, OG, I can easily choose, let's say, O to E. And then after that, I'll travel from E to the point H. But I do not have any much information on EH yet. But what do I know about the vector EH? E to H is the same or exactly equals as the vector F to G. So in this case, I'm going to use OE is 0, 1. And then I'm going to find E to H. E to H is the same as F to G, which means F to G is AF to O plus O to G. And that gives me 0, 1. But FO and OF is opposite in direction, so I'll get 2, negative 2, plus OG is 1, 3. Oops. And adding all this together, I'll get OH to be 3, 2. Remember, let's go back to the question. They want us to find the coordinates of H. So therefore, coordinates of H is X unit is 3, Y unit is 2. Now, this is not the only method in order to find the coordinates of H. We can alternatively take O to G or O to F plus G to H. And in this case, GH will be equals to FE. So it will be OG plus FE instead. And we can use a similar method to find OH. So in the parallelogram, we should make use of the equal vectors. Have you gotten the answer? Next question, question number 6. A is the point 6, 2. So B is the point negative 3, 8. Therefore, please write down the important information. Now, question asks us to find column vector AB. So how do I travel from A to B? I know that A is related to O and O is related to B. So AO will be and OB, and the answer for AB will be negative 9, 6. Find the magnitude of AB, and that will give us the answer to be 10.8 units. Part C, given that BC is this column vector, express OC as a column vector. Now it tells me information that B is linked to C. So in order to find OC, I'm going to use O to B and B to C. So O to B is vector negative 3, 8, and B to C is 5, negative 7, which gives us the answer 2, 1. Part D. If AD is given as negative 7, 1, name the quadrilateral ABCD. What is this talking about? What are some of the possible types of quadrilateral that we can have? Before we begin analyzing this part of the question, let's summarize this important information that we have. Now we know that if I were to have a quadrilateral A, B, C, and D, they need to flow in the correct direction. Let us make a quick sketch of this diagram. I have point A, and A to B is given to be the vector negative 9, 6. So that means I'll probably travel negative 9 and then 6 units up to give me A to B at this point. And I know that B to C is 5, negative 7, so we'll probably travel 5 and negative 7. So somewhere along here, this point will be C. And now they tell us that D is, A to D is the point negative 7. So negative 7 and 1. So this one will tell me that point D is somewhere here. So I can see quite clearly that BD is not parallel to AC, but I do not know whether is AB parallel to CD. So we need to analyze these two vectors. So I know that AB is negative 9, 6. And let's take a look at how to find C to D. So I'm going to A to B direction. We will find a C to D direction. So C to D will be C is connected to point O, and then O will travel to somewhere such that the point will bring me to D. I know that D is related to A, therefore I can travel to OA. So CO and OC are opposite direction, so we get negative. OA is 6, 2. AD is negative 7, 1. Simplifying this, we get a vector negative 3, 2. What do we observe about the vectors AB, negative 9 and 3, negative 3, 6 and 2? Well, it can be observed that AB is 3 times of CD. Hence, AB is parallel to CD, but they are of a different length. They are not equal in length. So if that's the case, then for ABCD will be a trapezium. Have you gotten the answer? We have come to the end of this part of the chapter. See you for the next lesson.